Hey guys, what's going on? So what I'm going to do in this tutorial is I'm going to go ahead and finish up the remote thing with you with the smart lights using like binary. So we're going to go through some code and kind of understand how to do this. So the first thing you want to do is, if you haven't done so yet, make your circuit. It's here. You could pause the video and look at where everything goes. Again, you want to put this stuff into data latch, all that stuff. What we also want to do is define a few variables. We're going to call it decode results. This will store the results of the IR blaster. We just call it results. And then IR, RECV, IRR, ECV. And this 5 means it's hooked to port 5, or pin 5, I should say. All right. So let's go to setup and set up the IR receiver stuff. This is pretty simple. We're just going to say IRRECV dot enable IR in. So that'll just say, hey, allow it to turn it on and listen. What this line does, this will just make this little L, LED next to the L blink every time we hit the, what do you call it? Every time we hit the receiver. All right, cool. All right. And let's just do... All right, cool. All right, that's pretty much all we have to do. Okay, so we're going to say if IRRECV dot decode and results. This just means we received a signal, okay? Okay, so the results.value is just the value of the results object. And then we have to say IRRECV dot resume. So this resumes it. Okay, so that's all we've done so far. So check this out. If I run this, RESULTS. Okay, what's going on here? What I type? Let's see. Decode underscore RESULTS RESULTS. Okay. Okay, let's see. A couple typos there. All right, so if you see that, like, for example, I hit 2, and where we got 2 is like FD8877, that's 2. If we hit play, that's FD805F, so we get FD805F, right? That's what we're doing there. That's all we're doing. So that's pretty easy. Okay, so that's easy enough. Okay, let's move on. So now what we need to do is the following. We need to figure out, let's just do this, what was hit. So we're going to say if results RESULTS dot value equals play. So that means we're going to hit the play button. What are we going to do if we hit the play button? Well, if we hit the play button, what we're going to do is this. We're going to say, we're going to shift out our number. So we're going to say digital write latch pin low. Then we're going to say shift out. We're going to say shift out. Data pin, clock pin first, and we're going to put on the thing called input. We don't have input yet. We're going to make it in a second. And then we're going to say digital write latch pin high to turn it to lock the key. And then yeah, that's what we'll do. And we could do like a delay of 200. So what's going to happen here is the following. When we hit play, we're going to input. We're going to write out our number. Well, we do have an input. Let's just, for example, let's just say 10. Let's try it. We have to say input dot toInt because input's currently a what do you call it? Input's currently a string. There you go. So toInt, well, we'll turn the input from a string to a number. So if we hit play and then hit play again, that's 1, 2, 4, 8. This is again 1, 2, 4, 8. 8 plus 2 is 10. Bam, we got it working. Awesome. And then after we hit play, let's go ahead and clear out the input. So we'll just say input equals quote quote. So what that'll do is I'll just clear my input. That's if it equals play. If it equals any other thing, we're just going to tack on whatever the user entered to the end of our input. All right, that's all we're going to do. So I'm just going to copy and paste this because I'm lazy. I'm going to say if results equals 1 or 0. And all I'm going to do is I'm going to say input equals input plus 0. I should put else. All right, and let's go ahead and do another one. If it equals 1. And let's do another one. If it equals 2. Let's test this out. And we're not going to start input 10 here. We're just going to start at 0. Okay? And we should delay on all these, just so we don't accidentally get two button presses. We don't want that. So we have 0, 1, 2. So let's do, I don't know, 20. Is this 20? 1, 2, 4, 8, 16. 16 plus 4, yes, it's 20. It works. Cool. So this is good. So all you guys have to do is do the rest. Now, what's the rest, Mr. Slow? Well, the rest is the rest of the numbers. Like, example, I'll do one more. If it equals 3, we're going to add a 3 on. 4, add a 4 on. 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. And that's it. Then you're done. And then you have smart lighting, actually. You have lighting that you could put in the binary digits and then get the lights you want around your room. Now, you could take that a step further, obviously, and you could say, you know, I want these two and these two, right? So that's, you know, obviously you could take that a step further, but what we have right now is really good. Make sure you clear out the input, because if we don't, we just keep tacking on stuff on the input, and our input will get really huge, and we're going to send a number to our shift register that's bigger than 255, and then we're going to get overflow. It's going to just actually mess with the bits, and you're not going to know what number you got, so we're not going to do that. All right, so for some extensions, if you want, you could try this, get some different patterns. These are what you're going to do. I'm going to put these up for you. These are the extensions I want to see you add to the project. I'll put this on. So hopefully you got a pretty good idea of the code. You understand, you know, what's going on, how it works, how this IR receiver thing works by just simply saying, if IR receive.decoding results, this line just says, hey, we received something, okay? Well, what did we receive? And these if statements are checking. Okay, so thank you for watching.